if you've ever really stopped to think about the chips inside. Well, everything. Our phones, our cars, the entire global economy. You realize they're the bedrock of our world.
They absolutely are.
But here's the thing that's just stunning and maybe a little unnerving. The tool that makes almost every single advanced chip on the planet, it comes from one company.
Yeah.
Just one.
And that is the terrifying choke point we're diving into today. Our source material comes from a commentary by Muad Rilwan, who's really dug into the structural fragility of our entire computing infrastructure.
And he doesn't pull any punches. His central claim is that we, as a species, have effectively handed over our entire computing future to this one Dutch company,
Yeah.
ASML.
Hmm.
Our source calls this dependency, and I'm quoting him directly here, the peak of insanity of humanity.
It's extreme language, for sure, but when you look at the facts on the ground, it's hard to argue with the sentiment.
It really is. So the mission for us today is, how did this even happen? How did one company corner the market on the most important manufacturing tool on Earth?
And what are the real risks that come with that? For innovation, for geopolitics, all of it.
Right. And then we'll look at the path forward he suggests, which involves a pretty big shift toward what he calls deep tech. So let's unpack this monolithic reality.
Okay, so we have to start with the technology itself, lithography. At its simplest, it's like printing circuits onto silicon wafers.
But these circuits are now, they're unimaginably small, right, down to the nanometer scale.
Exactly. And to do that, you need machines with a level of precision that is just mind-boggling. ASML isn't just selling a piece of equipment, they're selling the only viable way to make the chips that power our world.
The source is so clear about this. He says their machines run the world, and the critical part is they are the only company that could do that.
Right.
But just saying they're the only ones, that's not enough. What is the actual technological barrier? What did they build that literally no one else on the planet could?
The secret sauce, the thing that shut everyone else out, is extreme ultraviolet lithography, EUV.
UV.
So instead of using normal light to etch circuits, this uses light with such a short wavelength, it's almost like an X-ray. Getting that to work, it required solving physics problems that engineers thought were basically impossible 20 years ago.
So this wasn't just making a better version of the old thing.
Not at all. This
Yeah.
was a complete paradigm shift. It took something like $10 billion in decades of R&D with partners all over the world, competitors like Nikon and Canon. They just threw in the towel.
Yeah.
It was too hard, the physics was too difficult, it was way too expensive, and it was taking too long. ASML just kept going. They kept throwing money and people at the problem until they cracked it. And that gave them a lead that is, for now, essentially unassailable.
Which brings us right back to that existential question from the source. How humanity let that happen? If the foundation of all modern tech rests on one piece of proprietary equipment, that's not just an economic issue.
No, it's a massive failure of, competitive foresight on a global scale.
And suddenly that phrase, the peak of insanity,
Yeah.
starts a little less dramatic.
It really does. When Rilwan says we just hand over our whole computing future to one company, he's not just talking about markets, he's talking about geopolitics, supply chain security.
So if something happens to ASML, if they have a production issue, or if a government decides to restrict access to these machines.
The entire global tech roadmap just stops, dead in its tracks.
But couldn't you argue that this isn't insanity, it's just the natural result of hyper-specialization?
Yeah.
They took the biggest risk for the longest time, and they won.
That's a great counterpoint, and in a way, it is. It's the peak of efficiency. But what the source is arguing is that for something this fundamental, efficiency can't be the only goal. You can't sacrifice resilience.
That total fragility is the cost of efficiency.
Exactly, and that vulnerability is made even worse by the fact that the industry is kind of hitting a wall right now.
You mean the technological wall? We're getting down to the atomic level?
Right. The source points out that going from below 1 millimeter is a huge question. We're getting very close to the physical limits of silicon. So when the future is already that uncertain, being totally reliant on a single, super expensive path,
The ASML path.
it becomes exponentially more dangerous. We should be exploring alternative technologies, not just making slightly better EUV machines.
And that's where you get this strange feeling from the commentator, this mix of being amazed by the technology, but also deeply anxious about it. It's like watching a tightrope walker perform incredible feats, but with no safety net below.
And if you look at where the market's attention is, where the investment is going, you see this huge disconnect. The money isn't flowing into solving this foundational problem.
No, it's going somewhere else entirely. which I think is the perfect transition.
Yeah.
Let's talk about where the market is pouring its money, because Real One uses NVIDIA as like the perfect example of this mania.
Yeah, he has a very critical take on this. He says NVIDIA has been so lucky for a long time because they've managed to ride two enormous hype cycles.
Two distinct hype cycles.
Right. First, there was the crypto boom, where their GPUs were perfect for mining. And now we have the massive, all-consuming AI boom.
The point being that NVIDIA's incredible success is built on these huge waves of market enthusiasm, not necessarily on reinventing the core fabrication tech underneath.
Precisely. And that's the context for his really strong warning. He says very explicitly that both of these cycles are overhyped and have almost created another big bubble for sure.
So while all the capital and the smartest engineers are flocking to AI applications,
Right. Chasing short-term profits and inflating this bubble.
the fundamental structural problem, the ASML monopoly, is just sitting there completely unaddressed. No one is funding the next great hardware revolution that could diversify us away from that single point of failure.
That is the dilemma in a nutshell. We have one choke point for making chips, but all the investment is happening at the application layer, which sits on top. It's why he says the future needs to be much more exciting and that there are many ways to make that happen.
Okay, so this brings us to the solution. This is his call to action, and it's aimed squarely at investors, at technologists. The way out isn't just to make things a little better, it's to diversify.
And the solution is to support foundational revolutionary change. He's very specific. Prioritize what he calls deep tech startups over application-based startups.
Let's break that down because those terms are important. What's the actual difference?
Well, an application startup uses the hardware and software we already have to solve a problem. Think of a new AI tool, a new social media platform, things like that.
Yeah.
Deep tech is about the fundamental science. It's about inventing brand new things, new materials, totally different computing models like neuromorphic chips, or even new physics like quantum computing. Deep tech changes the foundation itself.
And he mentions quantum computing specifically, right? As an example of something that could completely shift us away from our dependency on silicon and just sidesteps the whole problem.
It's the ultimate countermeasure. If you're not using silicon wafers and traditional lithography, suddenly ASML's monopoly doesn't matter as much. So the strategy is clear. The community needs to support more deep tech startups rather than application-based startups.
And that really ties the whole argument together, doesn't it? The way you solve the single point of failure problem with ASML and the way you escape the bubble economics of the AI hype
Is by funding the stuff that comes next. By shifting our resources from optimizing the software we have to inventing the hardware of the future.
It's about making sure the next generation of computing is defined by new scientific breakthroughs, not just by what one company is able to print for us.
A powerful, powerful argument.
This has been a really fascinating deep dive. Just to quickly recap the main takeaways from the commentary. First, this ASML near monopoly on EUV lithography is a huge structural risk, a global choke point that the source literally calls the peak of insanity.
Second, that dependency is a real threat to our future, especially as we start hitting the physical limits of current chip technology.
And third, the solution he proposes is a conscious, community-wide effort to channel money and talent toward deep tech, to invest in diversification and build a more resilient foundation.
It's a really strong warning about choosing long-term resilience over short-term efficiency.
It is. So given that urgent call for a change in strategy, here's a final thought for you to chew on. If deep tech breakthroughs take a decade or more, and they need enormous amounts of capital, the same kind of long-term bet that created ASML in the first place, how do we redefine success in today's market to favor those bets? How do we make patience profitable again when everything is screaming for quarterly returns?
That would mean rethinking the entire venture capital model as we know it.
It just might. We'll see you next time on The Deep Dive.